Okay, section 4.1, question P6. And this is a very, very important question because it's one of the ones that you could potentially use in your life most coming from this course. Not with pumping gas, but the concept of course. So we have a population that is 2/3 women. So it's mostly a female population. And we have a stratified random sample of 100 women and 100 men. So first of all, you might notice that we're choosing equal numbers of women and men, even though our actual population has a lot more women. You might wonder why we would do that. So in research, often we'll do that to make sure that we get enough people from some minority group or some group that's not very represented in the population. This allows us to get a high enough sample size from that group so that we can do different analyses. And anyway, we find that 83 of our 100 women pump their own gas and 70 men pump their own gas. So apparently the women are not from New Jersey, which is a place I lived for a year, and you are not allowed to pump your own gas. And we need to figure out the overall population proportion. So the first thing you might think is, well, 83% of women pump their own gas, which is true according to our sample, within our sample. 70% of men. So let's get an average of those two. And your numbers may be different here, but the concept is the same. So in this case, we would take 83 plus 70, we would add them together, divide by 2, and we would get 76.5%. So why isn't this right? Well, let's take a quick look at a picture here. So this is an example of a stratified sample. In this case, we have a lot more men than women, but we are choosing 3 women and 3 men. So this down here is the actual sample with 6 people. And notice in the sample, they're equally represented. Now let's say in this sample, for example, I don't know what we're testing, but we get 2 out of our 3 men do something, and none of the women do it. Well, if we then went back to the population and said, so that would give us an average of 1/3, and actually that wouldn't be too far off in this case, but if we look at 1/3 of the population here, that's not going to be really representative because it's 2/3 of the men, but 0 of the women. So we would have 0 of these 6 women and 2/3 of these men. That's what a stratified sample would do. We're looking at the proportion of each stratum instead of considering every stratum equally. So in this case of our problem, we have 65% women, 35% men. We want to weight these women more heavily. So whatever proportion we come up with for this sample, we want to make sure that this gets most of the weight, or at least a lot more weight than the men do, because our population is mostly women. So in my numbers, I had 83% of the women. So I want to take 83.83 times this weight, this is the weight for the women, plus 0.7 times 0.35, which is the weight for the men. So notice what's happening here. This 0.65 and 0.35, they add up to 1, so the weights should add up to 1, but it's going to put more emphasis on this 0.83 than it is on this 0.70 right here. And so if I combine these then, I get 0.78, which notice is a little higher than that 76.5% that we would have gotten if we just took a direct average between the 83% of the women and the 70% of men. Okay, so these proportions in the population are weights. Now I mentioned that you would use this in real life. So a beautiful example of this is in classes like this one. So in our syllabus, we have 30% of the homework as your final grade, 20% coming from quizzes, and 50% coming from exams. So at any point in the course, you can actually figure out your own grade by using the same weighting system. So you would have 0.50 times your exam grades, 0.30 times your homework grades total, and 0.20 times your quiz grades. And of course, each of those, when I say grade, I mean what your percentage is of getting the things right in that category. Okay, so the main point is when we take a normal average, each thing gets counted equally. When we take a weighted average like this, certain groups or certain items may get counted stronger in the average. In this case, the women were counted stronger, which is how we got our 0.78.